Now let's do some hypothesis testing. Okay, and for that we have to make the same 4 assumptions like we did in simple linear regression. So that is, we have to have the model is that, okay, and the y values come from a normal distribution that has a mean, that has this for mean, and all the variances are same and they are independent. And we can represent that in terms of E as well. So we can say E comes from a normal distribution with 0 mean and sigma squared as the variance, okay, and y is given by that. Okay, so these are the assumptions. So test of significance, first thing you have to set up a hypothesis. What is test of significance here? Now the regression is said to be significant in this case. So we have 2 slope coefficients, not one like previously. So if both are 0, then the regression is not significant. Okay, so at least one should be different from 0, then the regression is said to be significant. So we have to set up the hypothesis in that fashion. Okay, so the null hypothesis, which is that the regression is not significant, is beta sub 1 equal to beta sub 2 equal to 0, and the alternative hypothesis is at least one slope coefficient is different from 0, is not equal to 0. Then alpha is the threshold for the p-value. So p-value, remember, is the probability of committing type 1 error when we reject the null hypothesis. So that's usually set at 5%. So now p-value, okay, the p-value for the overall significance, okay, is here from the regression output. All right. So now what is the conclusion? Since the p-value is less than 5%, we can feel free to reject the null hypothesis. The probability of type 1 error is really small. Okay. Reject H sub O because p-value is less than alpha. So how would you interpret this? Okay, you interpret this as we have sufficient sample evidence to conclude that the regression is significant, and the probability that our conclusion is wrong is 0.28%, 0.218%, or 0.22%. Okay. Now we can look at individual significance also. Right now, this is overall significance, right? Both slope coefficients are 0, or at least one is different from 0. So now that we have rejected, we don't know which one is different from 0. Are both of them different from 0, or just one of them? If so, which one? Okay. And for that, we can use the individual p-values. Okay, so we'll change that to a percentage and increase decimal places. Of course, remember, intercept we are not interested in, only the slopes. Okay, and as you can see, the p-value for beta sub 1 square footage is very small, so we can say beta sub 1 is different from 0, and beta sub 2 also p-value is very small, less than 5%, so we can reject that beta sub 2 is 0 as well. So both slope coefficients are significant.